Particularly, you may be a fresher, or you may be someone who is coming from a different background, maybe application programming background, or maybe database for that matter. And then you may be looking to move or transition towards a career that is specifically focused on some specialized services around data. So as you know, everything today is revolving around data. This is where majority of the traction is towards in the IT industry today. Every organization, whether it's a product-based organization or a um, consultancy-based organization, that is service-based companies, um, they have all structured their themselves into units that focus specifically on these data services. Okay, so it's very important that we all understand this. This is going to be there. This is something that is um, gaining humongous amount of attraction across the globe, because you see, we are all living in an era where data is being produced like anything, right? We are all on Facebook, Twitter, social media, internet, and then every now and then you are producing data in one form or the other. As we are speaking now, and you are watching this video, and I'm making this video, I am also creating some data, right? So it is all about data these days. So it's very important that we align ourselves to this new era. Okay, so for some of you, I think this might be a very, very basic concept that you are already aware of, and there's nothing new in that video. So apologies if you don't find it useful. But this video, like I said, is specifically meant for freshers, for college students, for anyone, even experienced people who do not have much idea about what this whole data world is all about, right? So I'll just try to give some idea based upon what I have seen so far. This may not be 100% accurate, but then this is one thing that you would find typically in most of the organizations today. Okay, so um, like I said, everything is around data. Now specifically, you can choose to be aligned into any of these streams within the data. So if you start, let's say, from one side of the spectrum, right, which is about um, ingesting the data, right? So basically, if you have an application here, right? So this is basically your application. It has got the business logic, it has got a data processing unit and um, storage and whatnot, right? So this is basically your organization, you can say, right? And then it basically gets the data from an external entity. So let's just say that there is this external entity, right? And this external entity produces the data that goes to your organization. Then your organization processes this data, and then it may be sending this data forward to some other external entities, right? Again, one good example uh, from the payment services domain could be something like when you swipe your cards on a terminal, right? You basically generate data. There is an event that gets generated. Now, this is where in the middle is your card processing company, or basically your transaction processing company, right? Let's call it a transaction processing company at a very, very broad level. So I'm not going into the specifics of whether it's going to be a network or acquire and things like that, but I'm just saying that it's a card processing company. It basically gets this data from an external entity, right? So from the terminal point of swipe, and then it processes it, and then it may need to, once the processing is done, at the end of the day, it may need to produce some reports maybe and send it to the external parties. So uh, everything right from the left hand side of the spectrum all the way to the right hand side is basically data governed, right? So if you look into this side of the things now if you are sitting somewhere in this organization and you're looking at both the sides, on the left side as well as on the right side, um, things that you would start off. So if you have to ingest this data, right? So you have to ingest. Ingest means, as the name says, this is an English word which basically means um, yeah, basically um, ingesting, right? So it's taking in basically. So it's just ingesting the data, which could be something like You could have streaming data, right? Streaming data is data that is streamed in real time. You could have batch data, which is, some files that you get in the form of batches every day at a scheduled time. Or it could be some other format. It could be a flat file. Um, it could be a CSV or some other way of processing the data. Now, now, when you have to ingest the data, the things that you need to take care of is how does the data be structured. So if the data is in a format that you are not able to ingest in, then it becomes difficult for your company to process the data. So it could be in a different format, right? Because this data that comes from the external entity uh, is not basically governed by you. You don't own that data, so you don't have a control over the structure that this data has. Now, what you have to do is when you get this data, and obviously you are supposed to get this data because you have to do the processing. So you have to ingest the data into a particular format. Now, because it's not in that format, you have to model the data. That is where the responsibility comes in for a data modeler, right? So um, this is one of the things, data modeling. Okay. Um, so the job of the data modeler is basically to see the structure of the data, right? How the data should be designed logically, physically, conceptually, um, in all aspects. So it could be relational data, it could be non-relational data, right? So again, I'm not going to this into the specifics of the type of data models there, but all I'm saying is it could be any format, right? So if you're looking at something like an Oracle or a Sybase side of the world, then you're looking at the relational data. But if you're looking at something like um, a JSON structured data or an XML structured data. This is more like a semi-structured data. Even more so, it could be a NoSQL formatted data. For example, if you're using any of the data sources like MongoDB, right, or Cassandra for that matter. So that's how the field of data modeling operates, right? It's basically meant to model the data in a format that is easily ingestible, can be stored, can be processed, and whatnot. The next thing is data architecture, right? So which is where architects who design the data come into picture. So their job is sort of basically data modeling to some extent. So you can say that data modeling is a subset of what a data architect does. Not necessarily, but data architect has sort of an end-to-end view of how the data should be architected, right? So he's also one of the guys who's going to take care of things like data governance, designing best practices around data, and things like that, right? So for any of these kind of things, whether it's data architect or data modeling, it's good that if you have experience on SQL. So um, it's basically writing queries, right? So the better you are in writing queries, the more comfortable you would be in taking up any of these professions like data modeling or data architecture, right? We can. I'm planning to create a separate series of videos on data modeling and data architecture down the line. But let me know in the comment section if you guys think um, it'll be useful for you. And if I find quite a few comments coming in over there, and I would definitely try to take some time out and create that video for all of you. So again, the roles and responsibilities of data architect is also to ensure how the data has to be stored, what kind of storage systems need to be designed. So today, data is not just stored on the relational databases, right? We're living in the era of cloud. So many cloud providers, AWS, Google, Azure. Um, it's important that as a data architect, you understand what each of these cloud services provides you, the capabilities in terms of storing the data. So um, it could be on-premise, right? So it could be on-premise where it could be a physical database where you're storing the data, or it could be cloud services. And depending upon the kind of services that you choose, the role of the data architect also determines the kind of security aspects around data, right? Because if you are storing the data on the cloud, you may not be able to store some of the sensitive data. For example, maybe the card number is a sensitive thing for your organization. You don't want to store it on the cloud because these servers are not owned by your company, but rather by Amazon or by Google. So you may not be comfortable storing the data on cloud, which is why you would want to still store sensitive information on premise, but rather more of the transactional data, data that is not very, very sensitive. You may want to push that on cloud. This is more like a hybrid structure, right? So very prevalent these days. Many of the companies are not going for one single cloud provider, but rather they would have something called as multi-cloud, uh, or a hybrid structure where they want to bring in best of all the worlds together. So, so that's about the role of a data architect in very, very high level. Then the next entity that comes into the picture is data engineer, right? Who is this guy? He's the guy who is responsible to ingest the data actually. So a data engineer could be somebody like a big data engineer, right? He's the guy who understands um, something like Apache Spark. If you have worked on any of the data processing engines, so it could be Spark, for example. But the idea here is that data, when it comes from external entities, has to be ingested. So so once it's modeled, once the entire architecture around governing the data and how it has to be stored, how it has to be ingested is done, then this is the team that actually writes the algorithms or creates the engine that actually does the job of pumping the data in, processing it. Now, when you pump in the data, you may want to do some further calculations on that data, right? Because you may need the data to say process it and then provide it to your internal applications for their internal consumption, or it could be that you may need that data to be processed and aggregated, and you may want to create some reports out of it. So, like I said here, right, again in this diagram, you may be processing that data that you have ingested, but when the data exits your company, you may be sending, say, some sort of reports. So again, in order to produce these reports, you may need to aggregate the data. So that is where the role and responsibility of a data engineer comes in, who uses some of these big data engines or big data technologies, um, and then he creates something called as aggregations and pipelines, right? So how the data would stream in, how it would come inside, then how the data would be aggregated. You may want to group the data on certain entities, right? So for example, if it's um, if it's payments again, you may want to group the data on, say, the kind of issuer, or the issuer, or you may want to group the data on acquirer or things like that, right? So it could be any entity you may want to group the data on, and therefore it's the responsibility of the data engineer to do that for you. And then he pushes the data into any of these storage systems. It could be, say, HBase, um, Hadoop, HBase, um, or any other data source for that matter. So there is a lot of, it's a very challenging profile, right? Anybody who likes to, you can actually do this if you have a background in, say, Java, or if you are having a good flair of programming. You're more of a guy who wants to uh, still be inclined towards programming rather than playing completely on the data side of the things. So you can pick up things like skills like Python, or you can pick up skills like Java, or any of these scripting technologies that help you to create the pipelines and do the aggregations and things like that. So that is the job of the data engineer. Okay. Further ahead, once the data engineer has done the job and he has created the aggregations which are then stored on some of these operational data stores, for example, it could be Hadoop or HBase, the then comes the responsibility of the next entity in line here. So I'm running short of space here, but let me just write it here on the left. So the next entity is the data visualization. Visualization. Okay, as the name says, this is the team that reads the data that has been ingested and aggregated, right? So here, if you see all the way here, right? So it reads the data from that storage system, which the data engineering team has done, right? And once the data is read, you may want to then use the data for some sort of analytical operations. It could be business intelligence or analytics, depending upon the kind of use case that it is. What I mean is, um, that if you um, if you are going to create some reports for the business users, right, on a daily basis, you may want to use the same data that has been aggregated by the data engineer, and stored in some sort of a storage system. You may want to read the data from that storage system, and then you may want to give the data to a visualization tool or a reporting tool. So what kind of tools are we talking about here? We are talking about tools like Tableau. Okay, we're talking about tools like ClickView, or any of the open source reporting tools if you are using an open source stack. So it could be an open source uh, reporting tool as well. Okay, so basically the central idea is that you use some reporting tool, again a very, very specialized area, and you read the data and then convert that into some sort of meaningful reports and dashboards. What are dashboards? So dashboards are nothing but again reports, but then the reports with which the users can play. So one kind of report is a static report where you don't have the ability to change the data. Once the data is generated and once the report is generated, it is a static one. It cannot be changed. It's something like daily reports that you get into your email, your mailboxes, or FTP'd into some location from where you can pick it up. Um, so those are the static reports. But then it could also be some sort of a dynamic dashboard where you may want to play around with the data. So maybe a dashboard where you have, say, a list of all the transactions that have happened, but you may want to see those transactions depending upon, say, sales or returns, or you may also want to see like maybe show me all the customers who have bought from this particular store on this particular day, right? So you can choose the store, you can choose the day, you can choose the hour, you can do all of those kind of things. So time series analysis and things like that is what you can also do there. The the as you go further on the data visualization side, it becomes very interesting when it starts amalgamating with analytics, right? So not to mix the two, data visualization is different from analytics. But then once you start moving towards high-end sophisticated visualizations and dashboards, you may be looking at things like from a more analytical perspective. You may be talking to people who are from analytics background. They create some algorithms and then they uh, structure the data in a way which is then displayed on the dashboard. Maybe you want to see something like, okay, show me the sales for the entire year of a shoe, right? Of a kind of a shoe, like maybe any shoe for that matter, right? I'm not taking any names here, but any of the brands you can think of which creates sports shoes, and then it wants to find out the sales that have happened over the given one year, right? Maybe state wise, every state, what was the sales, and then it may also want to see some outliers. Maybe what are outliers? Outliers are things like which do not follow a regular pattern. So you can think like maybe there is a constant sale that you can see of a given shoe model, right? Or maybe 5 or 6 different models. They are selling constantly every year, every quarter, every month in a given state. But there is this one particular model that has either sold very high or sold very less as compared to the other models. So that becomes an outlier, right? It doesn't follow the regular pattern. So for all of that kind of analysis also, you can look at data visualization here, which is what typically we do. This is where the USP of tools like Tableau and ClickView comes in. So that's about the data visualization. And then as you move higher end, you will be looking at more sophisticated technologies. For example, data science, right? So what is data science? Now you have the data here, right? Like you would have seen this data that was stored by the data engineer guy into the Hadoop or HBase. Before giving this data to the data visualization here, you may want to do some additional operations on the data, some additional algorithms. Like I just gave you an example on analytics, right? You may want to see the outlier, but that's a very, very basic example. But you may want to do some more sophisticated things with the data. Okay, so there is a new discipline of that particular field, which is called as data science. I'm sure you would have all heard about it. Um, Again, for people who want to jump into data science, I would say don't jump into it if you are completely new to the field of data, because you may find it a little difficult to adjust it, or you may not find it suitable to your taste, and suitable to your skills. So what I would really suggest you is, if you are coming from somebody who is a traditional IT background, right? For people coming from production support projects, let me just put it here, right? For example, if you are coming from Okay, let me just take the space. If you're coming from a background of production support or uh, Java J2EE application programming, um, or you are coming from database management or DBA, um, DBA skills, or you are coming from um, any of these kind of things, right? Then I would really recommend you to see what is it that fits in for your skill set. So if you are a production support guy, maybe you will find it easy to pick up something like a data modeling to start off with, right? Which is not a completely technical thing. It's more of a techno-functional thing, because when you are a data modeler, you would also need to understand the domain. So for example, if you are a data modeler, you would need to model the data on a particular domain. Now that domain could be either a banking and financial services domain, or it could be retail, or it could be logistics, right? Or it could be hospitality. So until you understand the kind of business that this is, how would you model the data? It's very difficult. You can't do that. So you have to first understand the domain, which is where people who are more of techno-functional. And why I said production support, because production support people are sort of techno-functional in nature, because they would have given support to the business users, right? So they understand the business, they understand the technology, and they are not masters of one particular field. They're like jack of all trades. So for people from production support background, it makes sense to sort of pick up something like data modeling to start off with, and then they can, once they start playing that role of data modeler for say 2 years or 3 years, they can start transitioning towards higher end sophisticated disciplines like data architect, because by then you would have that confidence to at least model the data, right? And when you start creating the models, then the next step is, about doing other things with data in terms of devising the right storage mechanism, security aspects, and things like that, which is where the role of the data architect then comes in. And so your technical skills will also slowly evolve. So that's the kind of transition that you should be looking for. If you are coming from somebody of a Java J2E background, I would recommend to look at something like data engineering, because you already understand a language like Java and J2EE, right? So if you're a data engineer, that experience is going to be very, very helpful, because let's say if you are a data engineer into something like Apache Spark, right? And if you are good into a language like Java J2E or Scala, uh, it is just that language that you have to use to write your own pipelines, your own aggregations, and things like that, right? So it's basically the scripting work that is being done by this language, but you already have a good command on it, so it becomes very easy for you then to pick up a skill like data engineer. If you're coming from a core database background like a DBA or something, maybe you can look at picking up a data visualization tool, right? Because you understand how to write the queries, right, very well. Or if you're a database developer, for example, you understand how to write the queries. So you're good at writing the queries. So half of the job is done, because when you are creating a data visualization, you have to pull the data from a data source. And when you have to pull the data from the data source, let's say in this example here, you are going to pull the data from Hadoop or HBase here, right? So if you are going to do that, you have to write some queries. So if you are good at writing queries already, then the next job is, or rather the half of the job remaining is to pick up that new data visualization tool skill, which is basically a desktop application, either Tableau or Click, or that for that matter, any other tool. It's just that you have to spend some time to understand how these tools work. Okay, so for people who are coming from database background, I would really recommend to see this route. Again, it's not a hard and fixed rule. It is something that I recommend. Again, it's all depending upon your own interest as well. And then data science, of course, is some for people who I would recommend that if you are from a database background, you can look at data science as well, because you understand at least the query writing skills and all of those things. So it's easy for you to start querying the data, right? Start playing with the data. But then you could also look at um, data science. Say you spend 2 years working as a data visualization expert, maybe a Tableau developer, and then you can slowly transition yourself by into data science. You can do some courses through Udemy or Coursera, or maybe you can do some certifications. There's a lot of certifications in the market these days in data science, and then you can slowly transition. What happens is, I have seen many people who, just out of interest, or maybe just out of seeing that some of their friends have joined data science projects or data science courses, they jump into it, but they don't actually have that sort of interest into data science, and it's completely normal. There's nothing wrong in it. What really happens is that maybe you are one person who doesn't want to spend too much time on writing algorithms and just querying the data, but rather you are very good in Java J2E, and you have that kind of a skill set where you can write typical complex aggregations. So maybe you align yourself more with data engineering, and therefore this is where you should be more focused on. But because somebody else was doing it, you start doing something about it, or read it, and then you know after 2 or 3 months your interest starts dying up. So my sincere advice is, don't just start any of these streams around data just on the basis of what somebody says, even for that matter what I say. But do your own due diligence. Now that I have told you what a data modeler is, now that I've told you what a data architect is, what a data engineer is, what a data visualization expert is, what a data science expert is, go read a little bit, see which is the thing that aligns best with what you're doing today. It cannot be a hard transition from, say, from Java J2E developer to data science in a period of 1 month. No, it doesn't work like that. That plan will simply fail. So my advice sincerely to all of you is that spend some time, see your skills, identify what is your core strength, what is your core weakness. If you need some advice, I'm more than happy to help you out. You can leave your questions in the comment section. I am not very frequent on going through on the comments, but I will try. I will definitely try. As soon as I pick up your question, I am going to respond to it, and I'm going to answer you. You can also connect with me on LinkedIn if you want to. I will leave my LinkedIn profile as well in the description. So you can connect with me on LinkedIn and you can ask your questions. But just leave your questions in the comment, and that's the best, because when you leave your questions in the comment, somebody else who have a similar question may also be benefiting out of it. So that way, your question can help others as well. So please do that. Okay, so that's about data science. You write some algorithms. Basically, and then you can do some sort of operations as well on data. You may want to transform the data. For example, ETL, right? Um, Many of you might be knowing ETL, right? Extract, transformation, and load. That was again a very popular discipline until a few years back. It is still today, but it has been, a lot of changes have happened. It's no longer a traditional ETL thing that we do today. So what we do here is we use tools like, say, Informatica, okay, or maybe Talend if you're using an open source offering. And what you do is you read the data from a source, you transform the data into the kind of format that you need in, and then you load the data into your system. But before you do that, you may be loading the data into a intermediary staging sort of a environment, and then you sort of go want to push it all the way to your higher environments or maybe production. So that is where ETL comes into picture. Now, data science is one discipline that cuts across many other things. A little bit of ETL, a little bit of query writing, a little bit of writing algorithms, a little bit of, not a little bit, but quite a bit of um, statistics. If you're good into mathematics and statistics, and you like, if you were one of those guys who used to enjoy solving probability questions or statistics questions while you were doing your engineering entrance preparations, or while you were doing your class 10th and class 12th, then maybe data science is something that might fascinate you a lot. So so this is a little bit about data science, and data science typically works in tandem, hand in gloves with data visualization, because once you do these operations on the data, right, you do some statistical operations on the data, you may want to display the data on a data visualization tool, which is where tools like Tableau and ClickView might be helpful for you. All right, so that's about data science. So roughly, um, I'm going to list all of these once again for you, just in case if you are interested to make a note of it, right? So you can just do that. So the first stream was data modeling. Okay. The second stream was data architect. The third stream was data engineer. The fourth stream was data visualization expert. Okay. The fifth one is um, data science expert. There could be more, but these are primarily the major ones, and some of the companies or organizations will maybe, structure maybe all of these three into one unit, and maybe this one and this one into another one. Some may be structuring these three into one unit. So it all depends really, but these are the different disciplines where if you are interested, you can align yourselves with. I particularly work, um, in the capacity of a data modeler, data architect, and a data visualizer. I started with a data visualization, and then slowly and steadily, as I got chances to um, move from data visualization to data modeling and data architecture, I picked up those chances. So I'm still learning. It's always a learning exercise. Every day is a new day for you and new day to learn. But yes, this is the kind of the channel that I chose. I had a production support background to start off with, and then slowly I moved into business analysis kind of roles. Then moved into um, from production support to business analysis, and then moved into data visualization, and then moved into data modeling, data architecture, and now it's kind of a role where it's sort of a union of some of these roles and responsibilities, right? So uh, that's how my journey has been so far. So if you have any questions, feel free to drop in the comments, and I'll be more than happy to help you. So I hope this video will be useful to some of you to figure out what you want to do next in your professional careers. And all the best to all of you. And thank you once again to all the people who liked the videos that I posted on the payment series. And I will try, definitely, I will try my best to be as regular as possible. I may not be doing, typical standard editing of these videos. I'm really hard pressed for time at this time, but my only intent is to at least uh, create some meaningful content that you may all find useful. And if you find this video useful, if you think that this video helped you to get some idea, some insights about the data and the streams around data, then I would also request you to please share this video with your friends, or anyone, your colleagues who may be interested, who may be looking for direction. I'm more than happy to help you all, and I'm here to help you. Thank you very much once again. This is Saurabh signing off. Thank you. Take care. Bye.